Hello everyone. Okay, so in this video we're going to be talking about cones. Yes, we're talking about cones. We're going to be finding the area and volume, or the surface area and the volume of a cone. So the cone is a formula that you need to be able to apply at leaving cert level. Anyway, it used to be on the junior cycle course, but then they took it off. I don't know why, but we will survive, as Gloria Gaynor once said. So a cone. So in this case here, we have a cone. It is just cone shaped. I don't know what you want me to say. So the volume of a cone is given by the formula 1/3 pi r squared h. Let me pick a brighter color there. So it's 1/3 pi r squared h. That is the volume of a cone. Where r is the radius of my cone at the bottom here, and h is my perpendicular height from the center of the cone. So this would be the center point here. This would be my perpendicular height. So basically going directly up. Then we have my curved surface area. My curved surface area is just, if I was to flatten out the cone, it's just a curved bit there, right? That's given by the formula pi r L, where L is my slant height. Now it's really important when we're trying to find our slant height, we're gonna need our perpendicular height and we're gonna need our radius, because we're going to be using Pythagoras' theorem to then derive what my slant height is. And then finally, total surface area. So if I'm dealing with a solid cone, right, I'm going to have a solid cylindrical circular base on it. So my total surface area is going to be the curved surface area of the cone plus that circular bit on the bottom. So this one is not in your log tables because you should be able to derive it from the other formula. In this case, it's just pi r L plus pi r squared, where in this case pi r squared is the circular base. So let's have a look at this question here. From the cone below, find in terms of pi the volume, curved surface area, and total surface area. Gorge. So let's label my bits. So obviously here my height is 12. I don't know my curved surface. I don't know my slant height, I should say. So my height is 12. My radius is 5. My slant height, I don't know what my slant height is. So we're going to need to use my Pythagoras' theorem. Now, so if you see here, I have a right angle triangle. Right? And I don't know what this is. So, I'll just call it L. L squared is going to be equal to 12 squared plus 5 squared. L squared is going to equal 144. 5 squared is 25. L squared is equal to 169. Square root both sides. I'm going to get L is equal to 13. So my curved, I keep saying curved. I'm not saying curved. My slant height is 13 centimeters. Good. Now I can start filling in my formula. So volume is equal to 1/3 pi r squared h. So it'll be 1/3 pi times 5 squared times my height 12. And then put this in your calculator. You are going to get 100 pi centimeters cubed, I believe. Yep. Right, next one. Curved surface area. I just say CSA for curved surface area because it's easier, isn't it? So curved surface area. So now that's given by pi r L. So pi times my radius times my slant height. So it'd be pi times 5 times 13. Which is going to be 65 pi centimeters squared. So remember, centimeters squared because I'm dealing with area. My first part is centimeters cubed because I'm dealing with volume. Then finally, last part, total surface area. So I have my curvy bit, and then I'm going to have the circular bottom at the end. So that is going to be total surface area is going to be pi or L plus pi or squared. Well, we know what pi or L is here, so that's going to be my 65 pi. Then the area of the circle at the bottom is going to be pi 5 squared, which is going to be 25 pi. Add them together, I'm going to get 90 pi centimeters squared. So that is the total surface area of my cone. Right, and it's that simple. So these are all in your log tables. You just look them up, or your formulating table. You just look them up, apply the formula, label your height, radius, slant height, bada boom, bada bing. That's it. Let's have a look at some questiones. So here's one example. Oh my god, spoilers. You saw nothing. You saw nothing. You saw nothing. Spoilers. Oh my god. I'm so ill prepared. Right. So let's have a look at this question. So a boy on the lake is in the shape of a hemisphere. The boy's a liar. Right. So a boy on the lake is in the shape of a hemisphere of a radius 21 centimeters, surmounted by a cone. Surmounted. Love that word. Right. Surmounted by a cone. The volume of the cone is equal to the volume of the hemisphere. So this seems like really important information. Right. Find the total height of the boy. So I need to find the total height of the boy. So I don't know what a boy is, really. All I know is he's a liar. But besides that, I don't really know what a boy is. I think it just floats in the sea and it does bits. I don't really know. But all I need to know is I have a cone stuck on top of a hemisphere. So I need to find the total height. So let's dissect the shape. So I have a hemisphere here. So a hemisphere is just half a sphere. And the thing with a sphere is the radius is the same all around the sphere. So that means the height of this hemisphere is 21 centimeters. Gorge. Then here as well, I don't know the height of this cone. I don't know the height. So I'm just going to say the height is x here. Do we know the radius of this cone? Yes, I do, because it's surmounted on this hemisphere. So therefore, it shares the same radius. So what's given in the question, the volume of the cone was equal to the volume of the hemisphere. Of the hemi, yeah? So 1/3 pi or squared h is equal to the volume of the hemisphere. So that's going to be half times the volume of a sphere, which is 4/3 pi or cubed. So this case, or is going to be 21. My height is going to be x. So I'm left with 1/3 pi times 21 squared times x is equal to 2/3 pi times 21 cubed. So let's sub this in. 21. 23. So I have 147 pi x is equal to 3. Bada boom, bada boom, bada boom, bada boom, bada boom. 6174 pi. Now I'm going to divide both sides by 147 pi. So divide by 174 I. By 147 pi. So 6174 divided by 400. I'm going to get x is equal to 42 centimeters. So what is x? X is the height of my cone. Right, so I find the height of my cone to be now 42. So the height of my cone is 42. The height of this hemisphere is 21. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . I don't have it there. Sorry. Right. So the height of my cone is 42, and the height of my hemisphere is 21. So the total height is going to be 42 plus 21, which is 63 centimeters. That is the total height of this boy. And yes, there was a practical problem involving a cone. So that is how you apply surface area, volume, and total surface area of a cone and an exam question on it. And I hope that helped, and I'll catch you later. Bye.